part is looking at determining redox reactions. So how do I know if I have a redox reaction or not? The point of redox reaction is that you must see that there's an element or a substance or a species that has been reduced, whereas another one has been oxidized. So you always go back to the point of, was there a change in oxidation state? So for example, I might have the following reaction. So I have hydrogen gas plus oxygen gas, and that gives me water. Okay, I'm going to go ahead and balance this because it wasn't balanced. Okay, so now I need to determine whether this is an oxidation reaction or not. So the first rule to determine whether you have a redox reaction or not is to assign the oxidation states for all of your reactants and all of your products and see if the elements have gained or lost electrons. So we'll notice that hydrogen and oxygen are in their elemental form, so they must have a charge of 0. In water, on the other hand, the hydrogen is +1 and the oxygen is -2. So then there's the next vocabulary word that you need to know, which is called half equations. And half equations represent the two halves of the redox reaction, one being for the oxidation and one being for the reduction. So, reduction and oxidation. So then I would write it out. Okay, so I've gone from 2 hydrogen to a hydrogen in a water molecule. Okay, and then I've gone from O2 to oxygen in a water molecule. In this case, I went from 0 to +1. In this case, I went from 0 to -2. What this tells me is, in this case here, I've become more positive. If I've become more positive, I have loss of electrons. And anytime I have loss of electrons, this tells me it's an oxidation reaction. In this case, I have a gain of electrons. I'm becoming more negative. And anytime I have a gain of electrons, this tells me that I have a reduction. So yes, I can safely say that this is an example of a redox reaction because I have a substance that has been oxidized and I have a substance that's been reduced. So if we were to take it a step further and say, what are the oxidizing agents and which ones are the reducing agent? Well, I can safely say that oxygen is the oxidizing agent because it oxidized hydrogen, whereas hydrogen is the reducing agent because it reduced oxygen, but it itself got oxidized. Okay, so this is a summary of how do we determine redox reactions based on the charges. Let's do another example. So the second example is also pretty easy to see. If I have a reaction between calcium and I form calcium 2 plus and tin metal. Is this a redox reaction or not? You can clearly see that you have two parts of this equation. One that involves calcium and one that involves tin. So I'll write them out. So the first step is make sure that it's balanced. It is balanced. So the second step is to look at the half equations. So the first half equation, I have calcium that has gone to calcium 2 plus. The second equation is that I have tin 2 plus and it has gone to tin metal. So then I need to determine which one is being oxidized and which one is being reduced. I know for a fact that this has happened because I went from elemental calcium to calcium 2 plus, and I went from tin 2 plus to elemental tin. So in this case, I have become more positive, so this must be my oxidation. In this case, I have become more negative, okay? So that means that this is my reduction. Now I need to represent this with electrons, okay? So to show which side is the electrons. Have I lost the electrons or have I gained the electrons? If I have lost electrons, then I am producing electrons for something else to pick it up, in this case the tin. So to represent that, I would write calcium gives calcium 2 plus aqueous plus the number of electrons that's in the charge. How many did I actually lose? There's 2 there, so I must be losing 2 electrons. So you can clearly see here that I have lost the electrons because I have produced them. In this case, I have tin 2 plus to give tin metal. So therefore, in this case, I have tin 2 plus that's picked up these 2 electrons to form tin naught. And because this is here in the reactant side, it must be reduction. So here from these half equations, you can clearly see that one substance has lost its electrons only to be picked up by another substance which has been reduced. So again, just to tie it together, in this equation, it is a redox reaction because the calcium has been oxidized by the tin 2 plus and the tin has been reduced by the calcium. And so we say that the calcium is the reducing agent, whereas the tin 2 plus is the oxidizing agent. Just to make sure that you get the concept, we will do one more practice question. If I have an equation like this, is this a redox reaction or not? Again, the first step is to make sure it's balanced. It is balanced. The next step is to make sure that there is a change in oxidation state. So I need to figure out what the individual atoms have as an oxidation state. So hydrogen is always plus, chlorine is minus, sodium is plus, oxygen is minus 2, hydrogen is plus 1. Okay, you can write plus or plus 1 means the same thing. Oxygen is plus, chlorine is minus, plus and minus 2. Then I look at the atoms in the reactants and I look at what happens to them in the product. So I'll notice that the hydrogen is plus in the reactant side and it is still plus on the product side. The chlorine is minus on the reactant side and still a minus on the product side, and the same with sodium and hydrogen. They did not change. So therefore, this is not a redox reaction. In fact, what it's called a neutralization reaction. And neutralization reactions involve acids with a base to get salt plus water. So, in summary, redox reactions involve the loss or gain of electrons, hydrogen or oxygen. There will be a change in the oxidation state of the elements going from the reactants to the products. If this does not occur, then you cannot say that it's a redox reaction. It will be another type of reaction, such as neutralization reactions.